picking up good vibrations.
Welcome to this very short course on signals. Signals are nothing more than functions of one or more independent variables. However, calling them a signal gives it an engineering flavor. The main goal while studying signals is how to process them and how to extract useful information for a given application. We are interested in questions such as, does the signal vary fast or slowly? What information does it contain and how can we extract it? Can we compress it without losing information? Among many other questions. Mathematical questions which we often stumble upon are addressed insofar as they help us in achieving our main goal. This short course is meant as a very brief introduction to signals for engineering students consisting of 7 lectures. It is specially intended for programs where only an introduction to signals is needed. Some engineering domains, namely electrical engineering, need to treat signals with considerable depth. This typically means more than 1 year-long course related to this subject. So what can we do with 7 lectures? Roughly, we can talk about many fundamental concepts, all evolving around the Fourier transform. This is an extremely important concept in many fields of engineering. It is so important that the theory of signals is often tangled with the theory of Fourier transform. If you fully grasp this Fourier transform, then you can easily understand other signals and transform concepts which we will not cover here, such as wavelets. Roughly, in the first 7 lectures, we'll focus on the continuous time Fourier transform and its properties, and some other important concepts such as the convolution and Fourier series. We'll also need a few basic concepts of signals and systems. In the last 2 lectures, we'll look at the discrete time Fourier transform, the effects of sampling, and the discrete Fourier transform. Especially this last concept of the discrete Fourier transform is something you can easily use to make yourself many interesting projects. The main goal of this course is then to empower you to conduct one such project or to use the discrete Fourier transform or the Fourier transform in many projects, engineering projects in your life. Now, many examples of projects that students have developed over the years can be found in these links. The Fourier transform can help you tuning a musical instrument such as a guitar or a piano, remove unwanted echoes from a voice signal, compress a signal, and much more. Now, why are transforms or transformations so important in general and the Fourier transform so important in particular? Have you ever tried to drive or remotely control a car or a quadcopter either in real life or in a computer game? It is considerably much harder than doing so when you're driving at the driver's seat. In the context of drones, a front camera can transmit data through virtual glasses that provide a view at the driver's seat, making our task much easier. The use of glasses allows to transform the initial position and orientation to coincide with those of the moving camera of the drone. Especially the rotation is rather important to understand if we should turn left or right and by how much. Now, the Fourier transform provides a very similar effect in the context of signals. For instance, if we want to identify from a voice signal in a time domain if it's generated by a male or a female, this is rather hard. However, it is rather trivial once you take the Fourier transform of the signal. The goal of the present course is to provide you with these new glasses with which you will see signals in a different way. I hope you enjoyed the short ride.